Good morning, good afternoon, good evening, folks, from wherever you're joining us. We're very excited to have you. Welcome to the Fine-Tuned Host Networking for Windows Server 2025 session. So today your presenters are going to be Basel and I. Both of us are product managers on the Edge Networking team in the CoreOS org. Jumping into a quick agenda for today, we're going to cover some new features that we're bringing to Windows Server 2025, starting off with Network ATC, which is a host networking management tool, Network HUD, which looks after your network health, and finally rounding it out with accelerated networking, which optimizes and accelerates your networking deployments. Moving on, coming into the host networking setup, right? Before Network ATC and Network HUD came into the picture, this is kind of like the problem statement that was presented to us. Deployment times for host networking setups were extremely high. They were very complicated with a range of properties, different types of deployments, and a lot of automated PowerShell script management required. It led to a lot of errors, support requests, and ICMs coming out of it, and it basically extended the process of deploying your host networking to multiple weeks, right? Even after you had host networking deployed, you still had a big hole in the form of operational analytics. You didn't know if your cluster was healthy or not. You didn't have a one-stop shop to check for everything being functional, and you weren't getting consistent automated alerts on your cluster health faults if something went wrong. Okay, diving in a little bit more, right? So pre-network ATC, this is what a typical host networking deployment looked like. Any network admin would have to come in and look at all of these properties from adapter configuration, which included RSS, VMQ, VMMQ, verifying adapter and network symmetry, to virtual switch configuration, and then setting up data center bridging for your storage networks. Finally, you would also have to configure switch versus switchless storage. And then if you had that, you would have to set up your stretch cluster. All of this was manual. You had to manually, individually make sure each property was configured correctly. Even with automated PowerShell scripts running, you had to make sure that the correct script version was applied to the correct sort of environment. Moving on, you would have to do this for each VNIC, for each virtual switch on every single node. And then you would have to repeat this on every other node in your cluster. And zooming out even further, you would have to repeat this on every single cluster in your fleet, right? So this was quite time-consuming, quite intensive, manually driven process, and there was a lot of gaps and scope for errors. So this is where Network ATC comes in, right? Network ATC's primary goal is to reduce the deployment time, complexity, and errors. Network ATC introduces a fresh concept called intent-driven networking, where you tell Network ATC, hey, these are the NICs we want to use, and this is the intent type we want to apply them for. And it's a one command setup, as you can see at the bottom of the screen. Network ATC takes care of a range of scenarios from adapter settings like RSS, VMQ, VMMQ, DCB cores, virtual switch configuration. Network ATC also takes care of proxy settings, cluster settings, live migration transport selection, live migration bandwidth limits. It automatically assigns storage IP addresses and ensures and enforces local and network symmetry. Finally, we also have some new features coming in with Network ATC, like custom subnet mask and some PowerShell documentation updates, and we're always looking to expand scope, right? So Network ATC comes in and takes what was previously multiple week support request full kind of a process and turns it into a 3 to 4 minute deployment, which is very automated, and it's easily replicable across different clusters, and you can scale from 1 to n within a matter of minutes. Having said that, we have a good demo to show you how you can start out in your testing environment, test out an intent, and then scale it to production within a matter of minutes. So here we have a demo on the copynet intent command line.
For the sake of this demo, Node 511 is our testing system and Node 512 is our production system. Here I run hostname to make sure I am on the testing system. I then create a quas policy override. We will later pass this as an override when we create an intent. This is to show how copynet intent takes care of all finer details, like overrides when copying over any intent. For this override, we set the SMB bandwidth percentage to 70%. I now run the addnet intent command with the previously created quas override to create a compute and storage combined intent. I wait for a couple of minutes and then run getnet intent status to make sure my intent has deployed successfully. We now go over to our production system and confirm that we don't have a pre-deployed intent. Here, getNet intent returns nothing, which confirms we don't have a pre-deployed intent. We now hop back to our testing system and run the copyNet intent command. Here we see the parameters needed for the copyNet intent command, which are the name of the intent we are copying, along with the source computer and the destination cluster. We now hop over to our production system. After waiting for a bit, I run the getNet intent status command to confirm that the intent has been copied over and deployed successfully to our production system. To confirm that our override was also copied successfully, we run getNet quas traffic class. The SMB bandwidth percentage is 70%, which matches the override we had created and passed on our testing system. We reconfirm that our override was copied over by assigning our intent to a variable and running intent.quasPolicyOverride. Here we again observe the bandwidth percentage field for SMB set at 70%. We have thus demonstrated how the copyNet intent commandlet copies over a validated and tested intent, along with its overrides and other minute configurations from a testing to a production system.
So with that demo being done, let's take a look at some of the new features that we're working on for Network ATC and we will bring out sometime this year, right? So let's start with RSS. What is RSS? RSS is basically receive side scaling. It distributes incoming traffic over multiple CPU cores, and its primary objective is to make sure that there is no traffic bottleneck over a single set of CPU cores, right? In the past, the way RSS was set up was the RSS override was mixed in with a lot of other NIC properties in the ATC world of overrides. RSS was set at an intent level. And lastly, the RSS logic was largely oversimplified, right? So the changes we're making will introduce some improvements. One is RSS will now be set at a NIC level, and so will its override. So this lets you tweak, configure, and have RSS set at a NIC level, which lets you customize more. We're working on some more nuanced default logic for RSS properties with Network ATC, which involves calculating max processor, number of queues available, etc. So you will also have access to some more nuanced default logic, which will require you to customize and override at a lesser extent. This feature ships by the end of 2025 based on current estimates, so keep an eye out for it. Moving on to another new feature that we're almost done working on is the subnet mask for storage intents. In the past, each storage network had unique subnets as well as unique storage VLANs for each NIC pair, right? But if you wanted a setup, let's say, where you only wanted one storage VLAN and multiple subnets, that required you to turn off automatic IP addressing, and you had to do every single step manually. It also prevented a customer from using the storage VLAN flag to customize their VLANs because they had to turn off auto IP anyways. So they would have to go through this entire manual process. Now what we've done is we've kept the same default behavior where each NIC pair has a unique subnet and a unique VLAN. But with the subnet mask feature, you can basically customize your subnets, your IP addresses, and your VLANs with two easy parameter flags, right? So you can pass the subnets you want, you can pass the storage VLANs you want through the parameter flags available on the addNet intent commandlet, and you can deploy a fully customized storage intent with just one command. You can still leverage automatic IP addressing and make your storage setup extremely easy, efficient, and simple. This will be available sometime in mid-2025, so keep an eye out around June or July for an announcement for this feature. Lastly, last time around, we received some feedback that we had some gaps in our PowerShell documentation. So we've spent some time fixing them and getting our PowerShell documentation up to date, right? So this documentation is updated on MS-Learn public pages as well as native PowerShell documentation. So if you run get help and the adapter name, you should see all this information populate on PowerShell as well. The changes include adapter, intent, and override commandlets, and the information we've brought on is descriptions, examples, possible parameters, parameter accepted values, so on and so forth. A quick way to check this out is just use the aka.ms link at the bottom of the page. So if you go to aka.ms/ATC PowerShell, you should be able to go through this Network ATC PowerShell documentation in a lot of detail. With that, we go from Network ATC to Network HUD. As it says on the screen, Network HUD is in private preview on Windows Server. So if you want to try out a feature which stabilizes, provides a lot of diagnostic and operational clarity, please try out Network HUD on your Windows Server 2025 clusters and give us the validation and feedback that we're looking for. This will be immensely useful for us as we go into public preview and GA. So what is Network HUD, right? Network HUD is an Arc extension, and therefore it enables us to ship out-of-box updates to it. So any bug fix rather, or any new health scenario that we want to ship, it ships to Network HUD right away through the Arc extension's out-of-box updates. Network HUD integrates perfectly well with Azure Portal for installation and enablement. And for the Network HUD health fault alerting, you go to the WAC cluster view, which is already familiar to a lot of you. Network HUD does use information passed on by your switch to make sure that what information the switch is advertising is consistent with what the host is expecting. So make sure that the switches you use are certified for Azure Local. So that's the same certification and quality we are expecting on your Windows Server 25 clusters. And as for diving a little deeper into Network HUD health issues, right? So Network HUD broadly has two categories of issues. One is spot checks, and the second is cluster-wide issues. Diving into spot checks, right? These are checks which can be done with just a few bits of information being collected, and they just need to be run in the background. Some examples of this include driver checks, making sure your drivers are not in-box. We will warn you if your driver is more than 2 years old, and fault if you have a driver older than 3 years. If you have NICs, for example, which are disconnecting or resetting very often, Network HUD will alert you before you see jitters in your traffic. Again, another example of NIC malfunctions can happen through PCIe bandwidth oversubscription. This is a common scenario we've seen. PCIe bandwidth oversubscription generally occurs when the link speeds on your NICs exceed the speed availability that your NIC ports give you, right? So this is going to lead to a scenario where you have, like, let's say 225 gig NICs and you're expecting 50 gig traffic to flow through, but your NIC ports have a limitation of 40 gigs combined, right? So this is going to lead to some traffic bottlenecking. So Network HUD is going to check this instantly in the background in an automated, consistent manner and alert you if this ever occurs. Easy enough steps, but a lot of times every single minute detail is missed by network admins. So Network HUD is always in the background, aware of all of these scenarios, ready to alert you. The second type of scenarios that Network HUD covers are cluster-aware scenarios, right? So this is where integration with Network ATC and reading LLDP TLV frames that we receive from the switch is so critical. Anytime a Network ATC intent goes missing, your cluster setup might start drifting away because Network ATC prevents this drift. So Network HUD will alert you if a Network ATC intent hasn't fully finished configuring or has configured and after configuration gone into a failed state. Secondly, with the LLDP parsing, Network HUD will alert you if there is any sort of inconsistency across your switch and your host. So a very good example of this is, let's say you're running storage VLAN S25. So your host networking is set up for VLAN 25 for your storage traffic. Your VMs, your workloads, all of them are on VLAN 25, but your switch is somehow not advertising VLAN 25, right? Let's say it's advertising VLANs 26 and 27. In this scenario, the VLAN 26 is going to get overburdened and the traffic on VLAN 25 is just going to be dropped and it's going to get bottlenecked on the second VLAN running. Network HUD is going to parse the LLDPs passed on by the switch, read that there is an inconsistency in this scenario, and alert you right away. Before your customer finds out, you can have a chance to go and fix it, right? So the entire objective with Network HUD is that you fail early and you fail inexpensively, and then you have like this sanity tool which is running in the background, making sure everything is configured, up to date, and functioning in an optimal state. Moving on, here we have two sample screenshots to show you how Network HUD looks like. So the first screenshot on top is Network HUD enablement through the Azure portal, right? So it's a very familiar user experience. You go to the Azure portal, you see the Network HUD tile, which says it's in preview because of the private preview we're currently in. You click on it, there's a flyout from the right, you hit the blue enable button at the bottom, and then your extension is enabled. On the bottom, what you see is a Network HUD health fault. This is a health fault that Network HUD will trigger and alert you to when there's some kind of inconsistency or mismatch with expectations, right? This is accessible through the Windows Admin Center cluster view on every server cluster starting with the 25 release. And moving on, finally, we have an end-to-end demo demonstrating how you can deploy your host networking from start to finish using both Network ATC and Network HUD. And we kind of walk you through how do you use PowerShell, how do you use the Windows Admin Center experience, as well as how do you enable and install Network HUD through the Azure portal. Here, we're deploying an intent on host TK511. We create a COAS policy override and set up the bandwidth percentage for SMB traffic at 70%. Once that's done, we use this override to pass it with our intent. Here we type in addnet intent and include the intent name, the intent type, as well as the adapter name and the overrides that we want to pass. Once that's done, we realize the intent has been passed successfully. We then run getNet intent status to confirm that the intent deployment was done successfully and has been completed. You can also use the Windows Admin Center Day 100 user experience extension to deploy Network ATC intents. You type in the intent name and type of intent that you want. You then select what network adapter you want to use for your intent. Once that's done, you go down and click on the blue create icon. You will see a green success status for a successfully provisioned intent. With Network ATC intents configured, we now show you how to install and enable Network HUD. We will also demonstrate how Network HUD flags health faults to keep your system healthy. Here we have an ARC-enabled Windows Server machine, which is part of a cluster. To enable Network HUD, we click on the Network HUD tile. We then see the flyout from the right-hand side describing Network HUD. At the bottom, we see a blue button which says Enable. We click the button to enable the Network HUD ARC extension. Once Network HUD is configured, we go back to the portal and we see the Network HUD tile have a green status which says Succeeded. You can view the health faults generated by Network HUD in the Cluster Manager view on Windows Admin Center. To find out more details, we double-click on the top health fault. In this example, Network HUD has detected an inbox driver. To fix this, you will have to upgrade your adapter driver. With that, I am going to hand it off to Basel, who will now talk about accelerated networking.
Awesome. Well, thank you, Param. I appreciate that. Hi, everyone. My name is Basel Kablawi, and today I'll be talking about the accelerated networking feature. Just to give you a quick agenda here, I'll dive into the background on SRIOV and accelerated networking itself. Then I'll be talking about how we are enabling SRIOV and comparing both the manual process as well as the new streamlined process that comes with the accelerated networking feature. I'll touch on how to install, and then lastly, leave you with some steps and just next action items in our call to action. So let's touch quickly on what SRIOV is. So SRIOV stands for Single Root Input Output Virtualization. It allows you to utilize finite resources on the NIC in the form of virtual functions and queue pairs, and actually allows you to bypass the host kernel and the host switch. And by doing that, we actually can see some benefits, mainly in the form of reduced host CPU processing, reduced network latency, and reduced network jitter. Now, SRIOV itself as technology has been around since Windows Server 2012. However, reasons when it comes to configuration enablement hasn't really seen it being used in a more widespread sense. Now, on the Azure side, Azure Cloud does actually use SRIOV as its default VM configuration, and that's where you'll see that branding as accelerated networking. So our goal with accelerated networking is to bring that ease and streamline enablement of SRIOV that you can find in the cloud, but to the edge. And so we're delivering that through ARC and providing a Windows Admin Center UI as well as a PowerShell user interface. Additionally, what this feature can do is it allows you to check your system prerequisites to say, hey, does my system support SRIOV? Will there be any problems when it comes to enabling, right? We also provide you the ability to enable and disable cluster-wide and then on a per VM basis. And then additionally, that extra layer of granularity where you can actually manage the VM performance settings in accelerated networking. And then lastly, leveraging on the great feature that Param talked about is monitoring health through Network HUD. So if anything does go wrong with the enablement or anything on the configuration changes throughout your process, you'll be notified and you'll know. So how exactly does accelerated networking simplify SRIOV? So I'll be going through an example here of a 2-node cluster where I'd like to reserve one of those nodes in case of failover. The idea here is if I enable VMs and for any reason one of my nodes go down, I still have enough virtual functions and queue pairs to maintain the performance that I expect for that VM. So in this case, let's go through the prerequisites and enable on the cluster. If I was doing this the manual route, there'd be a number of steps that I had to be aware of. I'd have to ensure that my host OS supports SRIOV. I have to make sure that there's a valid network ATC compute intent. You can see we're leveraging some of the great networking features that we talked about earlier. We have to verify that SRIOV is supported on the adapters. Additionally, does the switch itself support through the BIOS? There might be some settings there that have to be changed. And then we want to make sure the driver version on the adapters is up to date and correct. And then lastly, we want to know the consistency setting for hyperthreading, if it's all enabled or all disabled, as this plays into the performance of the VM. Now you can see all of these need to be done manually, but when it comes to accelerated networking, you simply choose your compute intent, you choose your node reserve percentage, you hit submit, and we actually will check all these prerequisites for you. And if anything isn't met or there are any issues, you'll be notified as part of the setup process. So moving on, we now have our cluster enabled. Now, the next step is how do we enable or disable a virtual machine? So there are a number of steps here to be aware of if you're doing this the manual route. Firstly, you want to determine what are my resource limits in my environment. In this case, it'll be in the form of queue pairs and VFs, like I mentioned earlier about SRIOV. So you can see here some sample commands you might have to run in order to get those numbers. The reason why you'd want to do this is in case of failover, you want to make sure that you have enough virtual functions and queue pairs. So some of these calculations and commands would need to be run. And then specifically, once you have your limits, does the host and adapter combination that I'm looking at actually support the chosen queue pair limit for virtual machines? And then continuing that process, once we've identified a host and adapter, we want to make sure we rename the VM next so we know that is the one that is managing accelerated networking. And then we are able to actually set the IOV weight, which turns on SRIOV. And then we can run some commands there to verify the VF was allocated to the VM. And then in the future, for any bandwidth allocation or performance changes, we want to increase or decrease the amount of queue pairs. So we're running through some of those commands again. And as you can see, this is all just for one virtual machine, right? So if you are planning a mass enablement, there's a lot more steps here, perhaps even some scripting that has to be done. And that isn't even considering any of the error checking that you'd want during that process. Now, with accelerated networking, you can see here, we can select multiple VMs and simply disable. The process works the same way as enablement. You just select your performance settings, and you can select one or more virtual machines. As you can see here, we're really streamlining that whole process. And for any sort of errors that might occur during this process, you're notified so you can take the necessary action. Speaking of the diagnostics and monitoring, so as I mentioned with manual, you really are just tied to what you are able to implement. If you do want to add error checking, obviously that's a lot more work on top of the initial setting up of SRIOV. So with accelerated networking, we do have some built-in checking. In the case here on the right, you can see that we tried to enable a 6 virtual machines, and one of them didn't have enough virtual CPUs to support the performance setting that we wanted. Now, in the manual, in the manual world, a lot of this visibility would either require you to go through some logs or perhaps take a deeper dive to find this information out. With accelerated networking, we do have a base set of errors and configuration missteps that we keep track of. And then additionally, with network integration coming soon, we can really do real-time changes, or if a VM is live migrated, ensure that the performance that you expect is maintained across that. So you can see a lot of great features, and it really does help speed up the process of SRIOV and add that extra layer of visibility and management that you wouldn't normally get with the manual process. And as far as installing it, it's actually pretty straightforward. So the PowerShell commandlets themselves are shipped in box. So as long as you're up to date on your Windows Server 2025 Data Center Edition, you'll have access to the commandlets, and so you can use accelerated networking through that process. And if you want to use the Windows Admin Center UI, you can simply just update your failover clustering extension in WAC, and you'll have access to the UI that you were seeing in the last few slides. With that, I want to thank you all for listening, and just want to call out just some last call to actions here. Please try out Network ATC, Network HUD, and Accelerated Networking, right? These are features that we're continually improving on, and we rely on your feedback to make sure that we provide the best possible feature for your networking needs. Something else I want to call out, tune into our networking deployment series blogs. So those are super helpful when it comes to understanding ATC, HUD, and accelerated networking. And it's a series that we're working on to just grant some more visibility and insight into the features that we're working so hard on, to ensure that we really help your entire networking process. And then lastly, for anything, any ideas, feedback, suggestions, or just want to say hi, please do email us at edgenetfeedback@microsoft.com. And with that, I will leave you with one last thank you, and we appreciate your time and look forward to seeing you in the next one.